Just everyone shouting.
I know it's really cold and green.
I'll answer the guy.
Yasmin, I'm just going to leave this here, so don't be concerned about a bag.
Sorry, what do you mean?
I'm just leaving my bag there. Just,
You want me to sit?
no, I just left my bag there.
Oh, okay.
Don't worry. It's not that someone's left the bomb.
Okay.
Thank you.
Yeah. I mean, I am wondering if there's somebody else. Do we just start, or is there somebody who please advise us with the online crew, etc.?
It was something.
I had come down.
That's the feed, so I think it's. There's
Just come here.
before. Now it says 30. No, now it says 36. So maybe the 270 was the
Okay.
registered. So it was like 35 online.
I speak to you.
I'm sure someone will hold a lecture.
What do your statutes say about quorum? How many people you need
You know
to
when
be
I'm
a
talking
quorum
about
at AGM?
say nice things.
I don't know.
We need to have 10 people. Which is
Right,
fine.
okay, so how many people do we have? Yeah. 1, 2, 3, 4, 5, 6,
And we have 10.
7. Yeah, really? Okay.
No,
So
second.
you have 10. So if there are no
EFET members, can you just raise your hands quickly?
I think I've said.
so I can.
EFET members, yeah, I think we're good. Yeah, okay, I think you guys
Yeah.
are as long as 10 is okay for you guys.
Okay, yeah, I mean, for me it's fine. Okay. Okay. Great. Good evening, everyone. Lovely to see everyone. For those of you who I haven't met before, my name is Yasemin Didem-Aktaş, and I am the chair of the IFIT Management Committee for the past 2 years. And here I am to tell you about our past year, which has been very hectic and very interesting. So I thought that I would start with the mission reports, because that, of course, remains the very heart of what IFIT stands for. We are very proud that we have published 2 reports this year. As you can see, both of them are heavily international. The first one was following the 2025 Myanmar earthquake, and the second one was the Eastern Afghanistan earthquake. As you can see, both contexts are those locations where the security concerns was high, travel restrictions were there, and also the diplomatic ties were rather weak, and hence the global post-disaster reconnaissance community joining forces for these reports for entirely remote report production activities. The first one was led by STEER, and the second one, as I'm going to expand on more in a minute, has been one sort of platform where we have deepened our collaborative relationships with the French Association of Earthquake Engineers, as well as University of Engineering and Technology in Pakistan. Apart from these 2 mission reports that we published and you can find online, we also have a number of reports that are currently in the pipeline. As we have discussed also at the last AGM, we are currently working on the Indian Ocean Tsunami Return Mission report, as well as Haiti, Nepal Return, and Morocco mission reports. And these are all going to be ready and available on our website in due course. But I also would like to make a point about the last year's April 23rd Marmara Sea earthquake, during which I was personally in Istanbul, and I have witnessed firsthand that it was a moderate event with a disproportionate societal resonance. And so we thought that we would put together a report where we are discussing all that basically panic that it caused, with some notes on the level of preparedness for an eventuality of a larger Istanbul earthquake in some future. So that's also going to be available very soon, actually. I probably need another couple of weeks before this is published. Okay, so our EFIT lectures. The first one, as you can see, followed very closely from the report that I just mentioned. So for that report activity, GHI, STEER, and ERI has been the leading organizations, and for this particular webinar, they also took the lead in the moderation role, but there were also those who represented USGS, Myanmar Earthquake Committee, and GEAR, and our very own GAUN represented EFIT. And the second lecture that we have published this year was delivered by Carlos Molina Hutt from the University of British Columbia and ex-UCL. It's an old colleague, actually. He talked about seismic design for functional recovery performance, a topic that is going to only attract more traction in the coming months and years. Research awards remains one of the activities that EFIT is engaged with, and we are most chuffed about. We have showcased 2 rounds of research awards this year. 2026 was presented by the University of Oxford's Yilong Yang and UCL Shahin Dede. But we also had another research award showcase from 2025 winners. And we also published 3 research award reports that are all available online. In addition to all these basically formal lectures and formal presentations and reports, etc., EFIT again this year has found a number of platforms for further dissemination and public engagement. This, of course, includes a number of conferences, including the upcoming European conference, where we have a number of papers underpinned by EFIT work. Our Moroccan team colleagues have very successfully organized and delivered a workshop in Morocco to their local stakeholders and told them about their findings. And all this work has been showcased in a rebuilt documentary, which made us all very proud. I had the opportunity to represent EFIT at the UK-Indonesia Solutions Symposium organized by BGS and supported by FCDO. And it was great to really have that sort of contact and reports to refresh the relationship with them. And all the other basically activities that you're seeing here, which is not in any way exhaustive, but just a range of examples. One thing that I think has been quite significant this year has been that we put together an EFIT missions archive. So as you know, the committee members here are all volunteering their time, and quite often we find ourselves in a position where we do a lot of work, but we are not necessarily the best organized. So after many years that we have discussed that, we should have a missions archive and we should have a map that actually shows all our missions, I sat down several months ago and basically pulled all the reports from 1980s onwards and put together some sort of spreadsheet which not only listed sort of all the events and report links and so on and so forth, but also the team compositions, the extent of local collaboration, and the scope of missions, which, among other things, led to this interactive map. If you haven't visited our website recently, please do so, because it's a very good, fun little tool where you can really zoom in and out and, jump to all the mission reports and so on and so forth, so it's good fun. But, so all this activity that I am mentioning, the mission archive, etc., has actually been motivated by another activity. It is a paper that is currently under consideration at the Bulletin of Earthquake Engineering, 40 plus years of post-disaster reconnaissance with a focus on methodological evolution across 3 phases of EFIT activity. I don't have much time to go into the details of this, but with the support of Mike Whitworth here and the University of Cambridge's Emily So, we have done a very extensive analysis as to how the methodological approach changed, by EFIT from 1980s onwards, but also what are the key changes in the key team compositions and approaches to data sovereignty, equity in co-production, and so on and so forth. So once this paper is out, Mike and I are very interested to deliver a lecture on this so we can hopefully discuss a little bit more our findings. Now, taking yet another step back for the past few years, I have been working with Emily so quite extensively, and we were really reflecting on the role of data, role of perishable field data, and what it means in the current time and age where we are using increasingly more advanced technologies like machine learning, remote sensing, etc. And some of those reflections last year have led to a special issue and an accompanying editorial, which actually taps onto the EFIT missions very widely and very deeply. So it might be an interesting read for those of you who are interested. Coming back to our collaborations this year, of course, ERI, GEAR, STEER, Map Action, Radar, etc. remains very strong collaborators that we work together quite strongly. But this year, we also continue to work with Tohoku University, Boğaziçi University, the Turkish Civil Protection AFAD. As I mentioned with the Afghanistan report, the NED University of Engineering and Technology, but also the French Association for Earthquake Engineering, and BGS, of course. And with this last one, I would like to give you another very specific update. BGS has approached us recently for a project called Hashtag. So they are aiming to develop an AI-driven platform that monitors natural hazards and their impacts in real time at a global scale. And of course, if something like this happens, IFIT would be one of the main beneficiaries of that. So following a number of conversations that we had with the Cambridge Architecture Research, the CAR, and also with our Sean Wilkinson, who actually is maintaining and keeping the photography repository from the LFE project, we have agreed to grant access to our repository for BGS for their machine learning model training purposes. And I am really hoping that we can report more on their findings soon enough. When we look into our membership, we have currently 96 full, 8 corporate members, and this includes a very new, basically, member to our family, AKT2, and 38 student members. I would like to thank all of them, which actually, is great, to feel supported in this way. It also puts us, our current balance at a very healthy level. But of course, despite that, and despite the fact that we have successfully negotiated with ISTRAC-T to be able to use part of our membership income for a mission, if needs be, funding to keep IFIT responsive to upcoming disasters remains an issue. If you remember, I have a couple of years ago put together an EPSRC proposal which has been unsuccessful, but I have got back in touch with the portfolio managers quite recently, trying to understand if anything changed in the EPSRC funding landscape and what we can do to fit. But also in the meantime, we have developed a number of bids, Leverhulme, some UCL internal bids, etc. So we are really actively trying to secure some funding for making us independent. Okay, so a couple of last updates. So 2 years ago, when I first got the chair role, I started an industry engagement working group, which has been led by Mariana Sinari, who has been absolutely amazing. So the purpose of this was really to develop a targeted engagement with our current and potential corporate members and industry stakeholders. So what we have done in that working group, we have developed a number of pathways to raise awareness and to disseminate the good work of IFIT to our corporate friends, through lectures and lunch talks, among others. But also, we are in a position to launch very soon a survey to our past and current members to explore a little bit more deeply where they see the value of being a member of IFIT, which hopefully is going to help us develop better strategies for deepening these links. On the right-hand side here, you are seeing a social media movement that we have also started with spotlights on our corporate members, etc., which has been received very well. Last but not the least, the training. As you know, IFIT has developed and several times delivered a training program. So, and IFIT's committee has been working hard to revitalize that, to revisit the training program and deliver it again. In the meantime, similar to the survey that I just mentioned, we have launched a survey among all our members to try to understand what their training needs are. And the main conclusion that we reached was that one single artifact, the training as a one single artifact, was not the way to go forward, but we should move to a more modular, flexible training program that is actually responsive to different training needs. We have, in the meantime, also asked them, for example, if they would prefer a training in person or online, and how many, or for example, how many hours they would like to commit to in one sitting of a training, etc. And all these basically findings have led us to think that probably a digital component to partly replace and support the traditional in-person and live online teaching components would be, again, the best way forward. Subsequently, I have approached to UCL digital learning platform, and they have agreed to host the IFIT training within their digital platform. And so we are working currently quite hard to review all our training program through those lenses. And so hopefully we are going to move partly to a digital platform very, very soon. I also must mention the name of Catherine Coates here, who has been an absolute star leading that particular working group. With this, I would like to give my thanks to all our corporate sponsors, and of course the IFIT committee. This is probably going to be my last address as the IFIT chair, and I must say that the committee has been absolutely fabulous, and they have made my job very easy going forward. So I'm very, very grateful to everyone. But last but not the least, we are of course always very grateful to ISTRAC-T for being our home, and Alan for supporting us in our work. Thank you so much.
Okay, so we move on to the second AGM of the night, the SecEd AGM. So I'm Damian Grant, the current chair of SecEd for the next 15 minutes or so. And then I'll be moving into the immediate past chair role, as I'll talk about. This is the agenda for this evening. This has been disseminated before the meeting. Kath, did we have any apologies for absence? No apologies. And we move on then to talk about the minutes of the last AGM. Anyone, any comments or queries or amendments for the last year's minutes? No, I'm not checking online. Probably I should as well. Not seeing any QA, but nor do I know where to look. Okay, I'm going to assume that's a no. And similarly, any matters arising from last time, there are none that I'm aware of, so we can move swiftly on. Okay, so just I've disseminated the chair's report in advance of this AGM. The rough agenda for the chair's report is on the screen. So first of all, just talking about the events that SecEd has held since the last AGM 1 year ago. We've organised about 16 lectures and seminars and 1 site visit over that last year. I listed all of those as an attachment to the chair's report. As you will have probably noticed, those of you who are regular attendees of our SecEd events, we have settled into a routine of roughly 4 meetings in the evenings at the ICE in person, always offered in a hybrid format, much like tonight. And those seem to be still the highlight, at least, of my involvement with SecEd. Lots of opportunity for good Q&A and social time afterwards. We also are running talks online only in some of those evenings, and when we can, trying to take advantage of that online only format to invite international speakers. So over the course of this year, our evening program has included talks, similar actually, overlapping a bit with EFIT's offering, on functional recovery design, as EFIT also had, the 2023 Morocco earthquake reconnaissance, borehole seismometer installation was the last talk we offered. We also had a joint talk with the Offshore Engineering Society on offshore wind turbine design. On top of our normal evening program that we've been kind of running in a similar format for decades, the Young Member Society also organize lunchtime talks, and they've continued to organize a number of such talks over the last year, 9 events in total over the last year, including one of the evening events in October to coincide with their AGM. They also organized a visit to the Schofield Centre at the University of Cambridge. Ahmed Al-Ziadani has taken over as chair this year. There he is, and is continuing the good work of his predecessors and bringing lots of good energy from that group into our main committee. So thank you, Mohammed. Thanks, Maria, for your work previously. Moving on to the Mallet Milne Lecture. So many will be aware that our Mallet Milne Lecture is our every 2 years prestige lecture. And so being every 2 years, and the term as chair is also 2 years, that means each chair gets to organize one Mallet Milne lecture. And it was my pleasure to invite Professor Michele Calvi from Pavia to deliver that lecture back in May last year. I think the sort of very best Mallet Milne lectures, in my memory at least, tend to be those where from the presentation you get why the person was invited, because they're able to demonstrate the real track record that sort of got them there in the first place, but also looking to the future as to what that track record kind of what that gives them in terms of enlightenment that they can pass on to the rest of us. And I think Professor Calvi's really ticked those boxes. It really showed us his work in post-earthquake recovery, and gave us some good thoughts for the future of that field. So we've thanked them before, but I think it's important to thank again both Professor Calvi, but also the sponsors of that event, gold sponsors Ramboll and Servotest, and silver sponsors AWE, Atkins Realis, and Jacobs. It's not listed in the printed chairs report, but some of you who are regulars on our website may have seen that we've announced the 20th Mallet Milne lecturer for 2027. So in May 2027, that lecture will be delivered by Professor Alan Rathje, and you'll see more information about that in the newsletter and on the website going forward. SecEd committee, so I'll talk later in the agenda about the elections to the committee in terms of the people who have left and the people who have replaced them. But before we get on to that, just to talk about a couple of individuals. First of all, we had our election of our new vice chair just before, a few hours ago, in our committee meeting this afternoon. And so I'm pleased to announce that Mark Scorer will be the new vice chair, and then he'll take over the reins as the chair in 2 years' time. So congratulations to Mark. And then just a couple of other individuals to call out. Andreas Nielsen's time as immediate past chair has just come to an end, or at least I guess in the next few minutes. And so he didn't stand for re-election in the committee. He will be continuing to help us with the incorporated status, which I'll come to in a minute. But really just wanted to thank Andreas for all his support while I've been the chair. And then much before that, he was a real force on the committee, and we'll really miss him when he does leave us. So thanks again, Andreas. Hopefully, I think you're listening online tonight. And similarly, Brian Young, who you'll hear from in a minute, there he is stepping down as well. He's served as our treasurer for the last few years. So thanks very much, Brian. And Wei Wei Sim is taking over wherever she may be. There she is. Yeah, thank you. So thanks for volunteering to take over as treasurer. I won't talk now about the elections, as I said, but just to say, when I was writing the chair's report, I was a little bit worried when I started because we had 6 vacancies on the on the committee this year, which is sort of unprecedented. And I thought we might struggle to get a couple of volunteers. In the end, we did have 10 people put themselves forward for election, so that was great, and I'll talk about the results of that soon. I've already mentioned the Young Members Subcommittee and their energy and their organization of lunchtime talks and things. But they've also had a couple of other projects they've worked on over the last couple of years. I think one of the most exciting perhaps is the SecEd Talks, the podcast that they've put together. And the season that they've kind of been working on over the last year has been the talking to people at sort of mid stages or end stages of their career to get advice around, earthquake engineering and structural dynamics careers. So they've talked to a number of people, including Professor Calvi, the last Milne lecturer. So it's been really good to listen to that, really professionally made and accessible from our website if you want to take a listen. They also support the SecEd Fund, which some of you may know is a fund that you can apply to get some support for your research project. And this year that SecEd Fund was awarded to Vikram Kumar Ramesh, a student at Strathclyde, and Nabila Abu Bakr from Malaysia. And we just heard actually just before that Nabila Bakr is available to come over and present in October in person along with Vikram Ramesh. So there'll be an event in October with both speakers, both of those awardees presenting their work. Just on the note of the SecEd Fund, the SecEd Fund will be awarded again this year. And if you're interested in that, that opens on the 1st of June. So keep an eye on all the different SecEd sources for that information. Another sort of long-standing tradition of SecEd is supporting the TK Heesh Prize, which has been going since 1979, awarded to a paper broadly in sort of topics related to SecEd's disciplines, so structural and soil vibration, and so on. And Guillermo has led that process for several years now, so thank you, Guillermo. And that paper was awarded, that award was awarded to Español Espinal and co-authors for their paper on investigating alternative foundation systems for offshore wind turbines in liquefiable soils from Geotechnique. And I know Guillermo is hard at work on the next batch of papers for this year's award. SecEd membership, at the moment we have, or at the time of writing at least, we had 395 individual members, which was a decent increase, 10% increase from last year. Most of those were students, which on the one hand they don't pay, so that's not so good for the coffers, but great in terms of getting punters in at an early stage, and hopefully they'll stay on as active members of SecEd. And we also had an increase in our corporate members from 13 to 16, so that was great. Just the last couple of topics, the relationship with the ICE. So this time last year I talked about how although we consider we make a really important contribution to the institution in which we base ourselves, the ICE, and certainly the ICE thinks that the specialist knowledge societies make a strong contribution as well. Unfortunately, just the commercial realities of this building being what they are, and One Great George Street needing to sort of balance their books, have meant that this time last year I had to report that the ICE was stepping down a bit of their support for us. They still give us access to this room for our 4 evening talks, but the online talks they're not really supporting us with anymore, and some of the other talks outside of those 4 that we no longer get for free. So that's had an impact on our budgets, which Brian will talk about in a minute. But you know, it's not all doom and gloom. This has kind of given us an excuse to have more frequent contact with some of the folks at the ICE, given an excuse to talk more to the other specialist knowledge societies. And so, you know, a mixed bag, I guess, of news on that front. But not a mixed bag, a very positive bag is the support we get from Kath as our secretarial support from the ICE. So thanks to Kath for that. I guess finally, to talk about our incorporated status. So this will come up again later in the agenda, as you'll see. But within the committee, we've spent a number of years exploring our legal status as a society. Currently, we're an unincorporated society, and we had looked into whether it was appropriate to become a charity, but that turned out probably wasn't worthwhile. But in investigating the status, we kind of came to the realization, I guess, that we as committee members had probably an uncomfortable level of personal liability serving as your committee. And so over the last couple of years, mostly led by Andreas Nielsen in the last couple of years at least, and with support from legal advice, external legal advice, we've concluded that SecEd should incorporate as a company limited by guarantee. And that if that were to take place, which we'll vote on very shortly, then the committee, the people who are currently members of the committee, would become directors of that company. So that would include the chair, vice chair, and immediate past chair, but also the other members of the committee. And as part of that process, of course, we would need to draft articles of association and bylaws, for which, as a model, we would use the existing statutes. From your perspective, as members of SecEd, we would hope we would continue to offer the same service and everything. But really, the main reasons that we're seeking to incorporate are such that the society can be a legal entity distinct from its members and managers, which makes more clarity around personal liability issues. It means the society will be able to sign contracts rather than individuals within the committee having to sign contracts and therefore being liable if things go awry. And also allow us, for example, to be legal, the society to be a legal owner of the website, for example, rather than having one of the committee members taking that on. And I've kind of mentioned this already, but committee members not being personally liable for SecEd's activities. We can't absolve ourselves of liability for criminal activity or gross negligence, which we'll try to avoid, but we'd like to sort of try and limit that as much as possible. So in a minute, I'll get back up here and ask you to vote on that resolution that we become a company limited by guarantee. But before handing over to Brian on the Treasurer's report, just on a personal note, it's been really, really fun the last couple of years. Thanks again to Kath for her support and to all the members of the committee. And Banali will be stepping into the role, and hopefully I can be as good a support as Andreas has been to me. Thank you. Over to Brian.
Hello, I'm Brian Young, your SecEd Treasurer for the next couple of minutes. As you've just heard from Damian, handing over to Wei Wei Sim. How do I go forward just next? They're the highlights, basically, of the accounts as of the end of December last year. So yeah, unfortunately this year we've had a slight deficit. I'll round this to the nearest £1,000, around £3,000. Compared to the previous year where we had a surplus of £3,000. The sort of operating costs for SecEd are generally fairly constant year on year, with a slight increase due to inflation. But then you have events such as the Mark Millen Lecture, which although we get sponsorship from companies, there's always a cost associated with that. Every other year in 2025, as such, had a Martin lecture, which explains the significant proportion of the difference between the 2 years. And the other part of that, as Damian explained as well, was the reduced budget of the ICE to support us, so having to finance extra meeting rooms. So that's the main reason why we've got, in terms of our bank balance is very healthy still at £85,000. Our income is about 75% of it comes from membership subscriptions, very consistent year on year. And obviously we get the support from the ICE, about £4,000 a year, which is consistent again year on year. So yeah, overall bank balance in a healthy position, but we get these year on year fluctuations due to Maltman lecture and conferences. Which takes us on to this slide here, which is in February the committee voted in favour of increasing subscription fees by approximately 4%, just because we see like the effects of inflation and also having slightly high operating costs to book extra meeting rooms. So we've just kind of rounded it to the nearest pound or the nearest £5 for the corporate memberships, but you can see the impact that it's going to have. But you know, in general, just to remind people of the services that SecEd provide to its members include obviously the series of technical meetings, the podcasts, the newsletters, the recorded broadcasts, which you can view through the SecEd YouTube channel, the website that's maintained, and discounted registration that members get of SecEd and SecEd affiliate events, the various networking opportunities, and obviously the membership of the European Association of Earthquake Engineering. So obviously I've heard I'm going to be stepping down at this point as Treasurer and handing over to Wei Wei Sim, but I'd just like to thank the ICE and the committee for their support over the last 2 years.
That's right. So we haven't been quite so disciplined with time as Yasmin was for EFIT, so I'll just move swiftly on. I already mentioned the election that closed last night, for which we had 10 nominations for 6 vacant posts. Quite a good turnout from the electorate. Thank you for voting. And so just without further ado, the 6 names that have been elected onto the committee, returning Manuela and Fabio, and then 4 new names. If your name's up there, congratulations, and we'll be in touch about what to do going forward. If your name's not up there, and if you're one of the 4 who didn't make the cut, then do stay in touch. I'll get in touch after this, and we'll look for ways in which you can be involved with SecEd, and obviously do try again next year. But thanks everyone, like I say, for putting their name forward, and thanks to everyone for voting. So moving on to kind of the main, I guess, business of the AGM is that we have this resolution that SecEd becomes a company limited by guarantee. So this slide just gives a very brief summary of what I already said before, which is that from the point of view of good governance of our society and better control over personal liability of the committee, we have, after several years of effort and external legal advice, have recommended that SecEd becomes a company limited by guarantee. I will ask that if you're not a member of SecEd, if you could just leave your hand unraised. And sorry, are there any questions or comments on this before we put it to the vote? Okay. In that case, like I say, if you are a member of SecEd, a corporate member, individual member, student member, etc., and you're in favour of this motion, could you please raise your hand? Okay, I don't know if I should be counting, but I think we can, thank you. And then if you're against, please raise your hand. Okay, so I think that was unanimous among those who voted, which hopefully is all the SecEd members in the room. Thanks very much for that, makes it much easier. So we, as it says there, the task is back on us now to continue with the process of drafting the articles and bylaws of the society, and by next time we will be a company. so you'll probably see more about that before the next AGM. Any other business? I've got one any other business item on the next slide. David, I don't know if you want to stand up in anticipation. So not seeing any hands. Just handing over to David quickly for the earthquake competition. You've seen him outside for this year's competition.
Do we have Mike Whitworth in the house?
It's the only reason I came.
So, just if you don't know about this, for decades now, we've done a predict where the next earthquake above 2.5 will occur after each AGM. There's a whole list of past winners, but last year you successfully predicted square 51 would have an earthquake before any other square. And so, yeah, with great pleasure, here is your champagne. And if anybody thinks that they can do better at predicting earthquakes, there are still squares available. See me after the meeting and I'll be happy to take you home.
Great. So last thing on the agenda is to say next time is the 28th of April. So see you all in 2027. And otherwise, I think we can move on to the evening talk. So again, sorry for going a bit over time on the business, the AGM. But tonight's talk, so we better get the new slides up, which they're already there. So before we introduce tonight's talk, though, just to talk about a few upcoming things. The May talk will be of interest both to the SecEd and EFIT audience here. We have a co-badge talk with EFIT, SecEd and EFIT, from speakers from the EERI Learning from Earthquakes program, so speakers from the US, and that will be an online talk in May, our usual last Wednesday of the month slot. June, the young members are organising another site visit to Servotest, which is one of our corporate members and one of the sponsors I mentioned of the Mallet Milne lecture, and they're kindly hosting up to 30 people apparently to come and visit their site. And registration's already open for that event. There are some places left. There is a limit of 30 people though, as I mentioned, on that event. So if you're interested, do get your registration in. And that will be on the 11th of June. And finally, I mean, we've got some other things kind of heavily penciled into the calendar, but I won't talk about them prematurely. But the Ziggy, as the EAEE rep for SecEd, asked me to remind you about the European Conference on Earthquake Engineering. Probably many of you will know about that already and have submitted papers, but for those who don't, that's being held in mid-September in Berlin. An early bird registration is open at the moment, so if you're looking to register for that, if you get in before the end of May, that will be at a discounted price. So that will be good, I'm sure. So over to tonight's event. We have a talk entitled The Second Generation of Eurocode 8, Key Changes and Implications for the UK. So our two speakers tonight are both members of the B5258 committee, the BSI committee, that is like the mirror committee for the Eurocode 8 main committee. So looking into the sort of UK-based issues of Eurocode 8. So Ahmed Elghazouli is the chair of that committee, a fellow of several institutions, fellow of the Royal Academy of Engineering, ICE, iStructD, and a past SecEd chair. And Ziggy Lubkowski from Arup, my colleague from Arup, fellow of the ICE, another past SecEd chair and EFIT chair, and the current deputy chair of B5258. And you know, there's a lot of people in the room tonight, and quite a few watching online. I'm sure it's going to be a really interesting talk. So over to Ahmed first, is it? Yeah.
Damian, can I just interrupt just very briefly and say thank you for chairing SecEd the last couple of years. Absolutely brilliant. I know you're in awe of Andreas, but you're a different character, softer, but just as thank you so much, and thank you to everything that you've done for all of us. It's really great having you as a chair, so thank you very much.
Thanks, Ian.
Yeah, thank you very much, Damian. So Damian has given me the task of summarizing work that we've done over the last 15 years in 20 minutes, so I'll do my best. But the first slide here shows the current arrangement of the Eurocodes, and you would see basically that we have Eurocode 8, the seismic design code as EN 1998, and this is what we are focusing on today. Now, this is the chapters within the first generation code, which was published in 2004, and you will see the different parts. Part 1, which is on the general rules and buildings, Part 2, bridges, Part 3, assessment, Part 4, tank, silos, and pipelines, Part 5, which is the geotechnics part, and Part 6, which is towers, masts, and chimneys. Now, of course, we have the national annexes for each of these parts, and these were produced a few years after the first generation code was published. This time round, we're trying to publish the national annexes at the same time or very shortly after. And this is the timeline that was basically produced by SC8. So you can see that the mandate started in 2010. It was planned to finish by 2023. There is just a delay of 3 years. But the target is basically to have all the parts of the code published in 2026. And this has been completed very recently. And the idea is that the withdrawal of the first generation will be completed in 2028 and replaced by the second generation. And again, you see that the national annexes are being produced at the moment. So some of the work has started, but hopefully most of it will be completed by the end of this year. Now, this was the purpose of the revision of the code. So we started with the purpose of simplifying the codes, covering new topics, harmonizing as much as possible with the focus on ease of use and reduction of NDPs. And I'll just give you an opinion at the end of how we've done with this. So this is how things have been rearranged. So there has been some harmonization in terms of basically trying to have all the general parts which apply to bridges, buildings, other types of structures in one part as general rules, avoid duplication. And then the design of new structures is covered in parts 1, 2, 2, and then 4 and 6 have been merged into 4 because they are different but very small parts of the code. And then the assessment of existing structures remains as part 3. Now, part 1 has been divided into part 1.1 and part 1.2 because part 1.1 is considered general for all types of structures, and part 1.2 focuses on buildings. So the restructuring basically looks like this. So part 1 has been divided into part 1.1, which applies to all types of structures, part 1.2, buildings, and then bridges, assessment of retrofittings of buildings and bridges. Bridges was not covered in the first generation. Now it's covered in the assessment part of the second generation. And then, as I said, part 4 and 6 have been merged into part 4. So that covers all these other types of structures. Part 5 remains as the geotechnics part. There is a new part which deals with testing, characterization. So again, the last available similar type of document was published in 1984. So this is quite a useful addition. It started for steel structures, but has been expanded to other types of materials as well. So this is the current status of the development of the codes. All the different parts have been published by the national standard bodies. So part 1.2 very recently, in the last month or so. But then interestingly, what I have under A1 is what we call early amendments. So we are now allowing amendments of the code very early on. So actually these are either being produced or in the process of being produced, and they will be available later this year as well as early next year. Now these are very interesting because in principle they are supposed to be minor amendments just dealing with editorial corrections and so on, but unfortunately some of it is technical. So we are supposed to be limited to about 10% of the length of the document in terms of amendments, and this has been a struggle in some cases particularly in part 1, 2, which is the largest and probably the one that created the most debate in terms of the code. And this is the one that has been delayed the most and only has been recently published probably in the last few weeks or so. So the national annexes, we are working on this, just subject to final changes and corrections and finalization, but most of it will be available by the end of this year or very early next year. Now, I've just compared here the length of the documents from the first generation to the second generation. So you can see that the length of the overall suite of codes has almost doubled. So it's much, much longer. So it is a bit more demanding in terms of looking at the documents, but at least we achieved the target of reducing the number of nationally determined parameters, and they are about half the number in the first generation. So at least this was, to a large extent, achieved. Now, some of the changes, there are quite a lot of changes in the second generation compared to the first generation. I've listed some of these, just some of the highlights. Basically, we have new structural systems and materials. The ductility classes have been redefined. There are some rules also for displacement-based approaches as well as force-based approaches. There is some guidance on tall buildings which did not exist in the first generation. Connections, there has been quite a lot of additions, and also deformation criteria, and I'll try very quickly to talk about some of these. Now, these are some of the new additions. Again, there is an informative annex on seismic zonation for Europe, which didn't exist before. There's quite a lot of additions on base isolation and supplementary damping systems. Flat slabs I'll mention very quickly as well. Aluminium now features for the first time. Assessment of bridges is included. Timber has been expanded and also covering bridges. And as I mentioned before, cyclic testing of components. Now I'll just selectively focus on a few of these because I can't cover everything within this short time. So I start with the consequence classes and limit states. So instead of importance factor, we are now basically trying to harmonize this with the other Eurocodes. So we now relate everything instead of importance factors, we are relating these to consequence classes. So that will be consistent with what we have with Eurocode 0 and so on. The limit state, again, are a bit more explicit and clearer than in the first generation. Again, the main design limit state is the significant damage, which typically relates to the 475 year. And there is a bit more consistency than the first generation in terms of how you relate the assessment part to the design of new structures. So this is much more consistent than before. And these limit states feature in different parts of the code depending on what you are designing. But there has to be always at least one ultimate limit state verification and one serviceability limit state verification. And again, this really depends on what you are looking for, what type of structure, what type of design you're doing. Redefinition of elastic response spectra. I'll mention this very quickly because I think Ziggy will talk about this a bit more later on. So as you probably all know now, we are sort of moving closer to what used to be the case in the American code. So we are looking more at the short period and long period definition for the spectra. So basically you now have to define the S alpha, which relates to, rather than in the American codes where you typically relate it to the 0.2 second period, this is more sort of an adapted peak value of the uniform has a spectrum, and then the long period at 1 second. And again, this typically is related to the 475 year, but there are a lot of options in the code on how you look at other return periods. Now, we started when we were developing the code by looking at basically defining the code in terms of S alpha and S beta. So, and that also takes into account the site amplification factors and the topography amplification factors. And again, Ziggy will talk about this a bit more later on. And as I said, this is typically for 475 years, but we also look at other return periods. And basically in part 1.2 of the code, for example, in all the parts there are tables like this, which looks at the return periods, or the default, if you like, return periods for the difference consequence classes and limit states. And you also have what we call the performance factor for, again, difference, limit states and consequence classes. So if you take the default values, and these two tables are nationally determined parameters, so you can come up with your own as a national annex, or for different national standard bodies, you can come with different return periods and consequence classes for the different limit states. If you take the default values, then these are the ones that are given in the code, and you can see that for significant damage at CC2, this is really the, if you like, the benchmark for all this is 475 years and a consequence class or a performance factor of 1. Now, European seismic zonation, as I said, this is an informative annex, so you don't really have to adopt it. And it gives two maps, which are S alpha for 475 for the short period spectral acceleration for 475 years, and also the long period acceleration at 1 second for 475 years. But as I said, each country will either adopt this or come up with their own maps in the national annex. And BGS, of course, has been working on this for a number of years. These are the earlier maps they produced, but as a committee, we've been very demanding, and BGS has been very helpful, is that we have changed that a number of times, and they've accommodated that quite a lot. So this has changed because of imposing different criteria, thanks to Ziggy, who's been sort of communicating mostly on this, so he'll talk a bit more about that. But you can see that there are some changes in the hazard, mostly at 2,500 years rather than at 475, but there is a change, and that has implications also on what we've been doing in terms of the national annexes. Now, I'll just remind you of the first generation on the definition of low seismicity and very low seismicity in the code, and this is very important because in the first generation, the low seismicity was typically determined based on 0.08 G, and the very low seismicity, where you don't need seismic design, was 0.04 G. This has been changed a bit in the second generation, and the most important thing is that this is not a nationally determined parameter anymore. So this is fixed. And basically you define that based on the seismic action index, which is determined based on F alpha FT, which is the soil and the topography parameters multiplied by the short period spectral acceleration at 475 years. And you basically compare that in terms of seismicity level for very low, low, moderate, and high, depending on that seismic action index. And if you look at these numbers, they are more or less the same as in the first generation in terms of the threshold. The main difference here is that obviously we're looking at meter per second square. We are looking at S alpha as the plateau instead of the peak ground acceleration. And also we take into account an average value of the site factor, which is 1.3. So it converts more or less to the same values. However, it's not a nationally determined parameter anymore. So you don't really have the flexibility of changing it. And that makes a lot of difference to the UK. So this is how the seismic action index was when we started drafting the code. But of course, a lot of countries objected to this, particularly the low seismicity countries. So it was decided to add a parameter called delta, which has caused us a lot of headache in the committee for the last few years, because that became a nationally determined parameter. And there is no real sort of background behind this, but we could change it if we want. And then the numbers that were put as recommended values were a bit on the high side, particularly for CC3 and CC3A and CC3B. I'll come back to this very quickly later on, and Ziggy will talk about it a bit more because it's quite important. The other thing is the explicit definition of behavior factors. So now we have an explicit definition of the overstrength part, the redistribution part, and the demand part. The redistribution part used to be called alpha U over alpha 1 in some parts of the code, but now it's explicitly referred to as QR. And QS takes a default value of 1.5 and as a minimum overstrength, if you like. And also there's a new definition of ductility classes. So instead of ductility class low, medium, and high, because of a lot of problems with ductility class high, particularly for reinforced concrete, it was decided to change to DC1, DC2, and DC3. In principle, DC1 is for basically elastic design with very minimal yielding or nonlinearity. DC3 is the full work of ductility, capacity design, and so on. DC2 is supposed to be basically just nominal ductility with some detailing for ductility, but without capacity design. In some cases, that was not possible, and you have to apply some simplified capacity design rules for DC2. So in the UK, because traditionally we haven't really been taking or considering seismic design, it's a bit too far a step to go for DC2, and this is one thing that we've been looking very carefully at, how to try as much as possible to maintain any requirement for seismic design within DC1. So in terms of behavior factors, again, the code will give you tables like this. In this case, this is for reinforced concrete, and you will see that there is an explicit decomposition of these three parts of the Q factor in terms of overstrength, demand, ductility, and so on, and redistribution. And again, this is for steel, and you will see the different values here for the different parts of the Q factor. Now, this is another very important part of this S delta, which is the seismic action index, because it's not only important in terms of deciding on the seismicity level you are in, there are also now upper limits for S delta that are imposed in the code. Again, trying to be a bit closer to what happens in the American codes. So you have for each type of material for different systems, for example, this is for steel. For the different types of systems in steel, you have an upper bound on S delta in terms of whether you can use DC1 or DC2 or DC3. And again, this is very important because you can see that there are some limits here of 2.5 meters per second square, which is relatively low. This is about 0.1 G in terms of PGA. So again, you have to be very careful about this value of S delta because it also imposes a lot of restrictions in terms of what type of system you can use. And this is in terms of reinforced concrete, and you will see that the value of 2.5 features quite a lot in some cases. So it really is very, very important what we decide in terms of these values of S delta. Now, I'm not going to talk a lot about this slide, but again, one of the important things we've been looking at in the committee was whether we take the recommended values for delta in the code or do we change it. And of course, the decision was to change it, but to what values? There is a lot of judgment that comes into play. Of course, we have to look at the hazard. And the other thing is that we've started some calibration studies led by UCL, and I can see that Shaheen is here. He's been doing a lot of work on this and coming up with a lot of interesting results that can help us in order to calibrate these values of delta. And we are sort of tending to use much lower values for this. And we are very likely to recommend that CC1 and CC2 do not require any seismic design in the UK. But there will be some demands for seismic design for CC3A and CC3B for parts of the UK. Now, anti-seismic devices, or that's what the code called them, which is basically include base isolation and supplementary damping, is very much extended in the code. Supplementary damping did not exist in the first generation. Now it features very heavily. And base isolation used to be only for full isolation. Now we have partial isolation as well. So It is covered in terms of full isolation, partial isolation, supplementary damping devices, and it is covered both in section 6.8 of part 1.1 and also for buildings in part 1.2. And this covers both displacement dependent devices and velocity dependent devices. Again, because of time, I'm not going to talk too much about this. Flat slabs, again, feature now. They were not allowed as lateral resisting seismic systems in the first generation. Now they are allowed because basically they're very popular systems. But of course, there has been a lot of collapses caused by flat slabs and a lot of issues with punching shear failure and so on under lateral cyclic loading. So now it is allowed, but with a lot of restrictions, and there are quite a lot of rules there, but you will see that there is a limit on the value of S delta where you can use DC1. There are also limits on how you can use it for DC2, and they are not allowed for DC3 at all. Aluminium structures also feature now in the code, so they have a separate chapter in part 1.2, and as you can imagine, this is very similar to what we have for steel and composite structures. So these type of structures now can be designed according to Eurocode 8. Aluminium and light gauge structures and so on, which are quite popular, sustainable type of structure, and now opened up in the code. Deformation criteria, so there are quite a lot of rules now added in part 1.1 of the code that helps you in order to undertake displacement-based design. They are also very useful for pushover analysis and also for time history analysis. So for all types of structures, for all materials, you have rules like this, where you have sort of component deformation characteristics for steel, concrete, composite, timber, masonry, and so on. So these are very useful additions within the code. So just to conclude, and I'm conscious of the time, this is just a summary of the key points that I tried to highlight within this very short presentation. I'll hand over to Ziggy now, who is going to focus more on the situation in the UK and also cover very briefly the geotechnical aspects. Ziggy.
Thank you, Ahmed. So, going to focus on seismic actions and geotechnical aspects. Those are the key areas I'm going to cover. So, seismic action class. Ahmed's made it very clear that this is the key starting point of what we need to do. We assess where we are. And the brackets that I've shown, for UK, we actually creep, if we use the recommended values, just into moderate. And that gave us in the committee a lot of headaches as to what we needed to do, because for a long time seismic's not been required. It's been excluded in the first generation of the national annexes, and this was pushing us to a point where seismic design was required. So a lot of sleepless nights. The seismic action classes in parts 1, 2, 2 and 4, they are all the same. In part 5, CC3, there's just CC3 rather than 3A and 3B, and it's a value of 1.5. So those are the recommended values. It specifically says in the code for very low areas, Eurocode 8 may be neglected, good for the UK. For low areas, simpler rules may be relevant. And that does impact us. Clearly, when we're moving to moderate and high, you've got to follow the detailed rules. And that covers a lot of Europe, but we wanted to make sure that we retain the status quo of where we were within the limits that were available to us. So just going back to the seismic definitions and the response spectra, as Ahmed said, we're now looking at a short period ground motion S alpha and a long period ground motion S beta, and they're a function of the site class and also topographic factors. the nominal ratio between the peak ground acceleration and the S alpha is 2.5, and that's been retained for the UK National Annex based on our latest decisions. We originally made the assumption incorrectly that the S alpha would be at 0.2 as per the American codes, and that's why a lot of the work that BGS did for the original mapping and then the offshore mapping presented the 0.2 value. If you actually go to the background document to part 1.1, you find a very complicated formula to work out what the average value for the peak of the spectrum is. This isn't in the code, it's hidden away in the back, and it was used to develop the European maps in the National Annex. In the Annex A of Eurocode 8, part 1.1. We've estimated that actually for the UK, S alpha of about 0.15 is equivalent to this complicated formula. So Ilaria Mosca at BGS has updated the hazard mapping and has now provided these values. And as of early this week, a new set of hazard maps have been provided on the BGS website and include this value. We obviously need to define the periods of the spectra. The short period value is a function of TC. TC is a function of the ratio between the long period and short period accelerations, and TD varies depending on the level of seismicity. Site categories have changed wholeheartedly, which is a really good thing from a geotechnical perspective. It's function of depth of the soil and the shear wave velocity. So forget about rock, stiff soil, soft soil. It's just based on shear wave velocity and the depth to a bedrock level where you get a shear wave velocity of 800 meters per second. You're recommended to derive all these parameters with direct measurements of shear wave velocity, but obviously that's not always possible, but that's the recommendation. And there are formulae, either set numbers for each site category or a varying number for a range of categories that you can derive the amplification factors for. This is just an example for a moderate level of seismicity for a shallow soil profile of 30 meters, an intermediate soil profile of 70 meters, and a deep profile of, I think it was 250 meters that I did this comparison for. And these just show you the amplification factors that are now in the code, and they're more significant than were in the previous version of Eurocode 8. The topographic amplification is very similar to what was previously required, but it's actually only focused on ground types A and B, and isn't focused on any of the other ground types. There is a very useful table 5.6, to give you the likely magnitudes for different ranges of acceleration, and on the right is just a comparison with some of the estimations of controlling magnitudes from the seismic hazard work done by BGS, and shows that the actual values that are tabulated work well with a selection of locations within the UK. So we're keeping those as is. Now, our favourite value discussion of delta. And as I said, the BGS team have developed new maps. They're based on the offshore mapping, which was far more detailed. We have now included 0.15 second and 1 second. these maps are now available. They will be in the GeoIndex later in the summer, so you can actually go to a specific latitude and longitude within the UK and pick up all the values you want for a range of return periods. Taking that data, we assessed what the seismic action classes were, be it very low, low or moderate. We never got to high. 4 different site classes. On the left we see CC3A, on the right CC3B, and everything inside the red circle got us into moderate. We couldn't accept that, so we reviewed what could be done. And on the left you can see an example for CC3B based on an assumption of a delta of zeros for CC consequence class 1 and 2, as Ahmed suggested, and then 1 for CC3A and 3B. And in that case, nowhere falls into the moderate range, but you have quite a large area through Wales and the Midlands on porous soil classes, which require some degree of seismic assessment, DC1 type approach. So that's really going to potentially affect schools, assembly halls, cultural institutions, hospitals, fire stations, data centres, etc. Quickly go through geotechnical structures. The geotechnical code focuses on standalone geotechnical structures in terms of defining consequence classes. These are just some of the examples. If you have a geotechnical structure that's directly related to a physical structure, a bridge, a building, then the consequence class of that bridge or building takes precedence. There is a far more in-depth assessment of damping ratios and strain reduction values than previously assumed, and all bar the cyclic strength partial factors are all now set to unity, which is far more sensible. There's more development on potentially active seismic faults. This chart is provided, and it's basically saying that if you have soil cover of a particular shear wave velocity over and above an active fault, you are allowed to build on it. The top line is for areas of high seismicity, line B for areas of moderate seismicity, and line A for areas of low seismicity. So if you've got 5 meters of sand overlying rock and you know there's an active fault below there, you're allowed to build on it in a region of low seismicity. But we're actually excluding that. Well, we're saying we don't need to consider faults within the UK for normal building design. In terms of defining the actual seismic actions for geotechnical structures, the formula 5.1 is what you need to look at, which is a function of a coefficient beta h, which looks at the spatial variation of horizontal ground motion for, be it a slope or a retaining wall. Chi h, which is an amplitude factor, and the peak ground acceleration, and it varies depending on this formula h over tm to the square root of g over rho. I haven't actually compared it to what you'd traditionally do, but it's assuming some level of averaging over the height of a geotechnical structure. And then the code provides different values of the chi h factor for slopes, retaining walls, and for foundations, for force-based design, or if you're doing displacement-based design, different displacement targets for the different performance levels that Ahmed presented earlier. And here on the left we have the equivalent values for foundations, be it shallow foundation or pile, and also it provides a lot of detail on plastic hinge strain limits for different limit states. This is very similar to the plastic hinge strain limits in the US codes. The final slide is just to highlight that there's a lot more information about soil structure and interaction in Chapter 8. I'm not going to go through the details of that. And there's a whole new chapter, Chapter 11, on underground structures with further annexes, Annex H in particular, which is based on the work of Youssef Hashhash, and that's all added to the code. So there's a lot of really good data that's been added to the code, but I think you'll find that some of the equations get a little bit overcomplicated. So I think it's a technical step forward, but I'm not sure they've achieved simplicity. I think that's it. Thank you.
Thanks very much, Ahmed. I've got some microphones here on if someone else's. Thank you. Yeah, so any questions in the room first up, please?
If there are no questions, maybe I'll ask the first one. So essentially, for what I can understand, and for having worked with Ziggy on the other part as well and providing comments, the design on a whole, you have to look at 4 different limit states and consequences. Do you think that it's going to become more effort needed, or do we have to train a new generation of engineers on codal requirements? What's your overall feeling about the effort that a typical consultant would put in a normal project in the UK, where obviously the first thing is, oh, you don't need to do seismic. I know you're trying to work on the delta factor, but generally, do you think we have to now really push this a lot more? What's your overall comment?
Yeah, I mean, it's an important comment. So I hope I didn't mislead you by putting all these limit states, but for most parts, significant damage is the check and another check for serviceability. In some cases, for example, when you're dealing with damping systems and so on, you might have to look at other limit states. And the same also applies to the assessment part, where you have to look at different limit states depending on what you're doing. But no, I mean, it's not that in all cases you have to look at the 4 limits. That's not the case. However, having said that, the code is more demanding than the first generation, so it will require more training. I mean, there is no doubt in my mind about this, that there is a bit more to know, and the code is, I mean, I know that we talk about ease of use, but it is really written with and it says that, for the competent engineer in mind, so it will require some training, definitely. Yeah. Do you want to add anything?
I would just say that you noted in the maps that I showed, Wales is a big area that's been covered, and Ahmed in particular has been in touch with the National Assembly or people responsible from Wales to actually look at the implications for construction locally.
One question for Ahmed. You mentioned one of the points was the change in tall buildings. Can you describe a bit more on what is changing there and the discussion that happened there?
Yeah, so basically there was no intention to cover tall buildings at the beginning, but then it started by a suggestion to change the damping values when we're dealing with tall buildings. Because as you know yourself, I mean, the damping is very low when it comes to tall building or the intrinsic damping. But then it sort of pulled a lot of sort of other rules about tall buildings and the type of analysis that you need to use and so on. So it's not an extensive guide in terms of tall building, but it's, at least it's explicitly mentioned now, which was not the case in the first generation. So it's really about damping, and it's about the type of analysis that you can do depending on the height of the building. And there's also a bit on soil structure interaction for tall buildings. So it's not a guide on tall buildings, definitely, but it's not excluded, and that's very important, because in the first generation, it was open to interpretation, whether you can use it, or is it actually included, or is it totally excluded. It wasn't very clear to designers, but now I think it is quite clear.
And on that broader topic of the sort of scope of the code, there's a question online from Lubkowski. Are special structures such as nuclear power plants, offshore structures and large dams going to be allowed to be designed using second generation, as such structures were excluded from the first generation?
No, I guess.
So you need to look at Eurocode 0, which explicitly says that nuclear and large dams are consequence class 4 structures and therefore are not covered by the codes. That doesn't stop you using the methodologies and the good ideas which are in the code as you could previously for those structures, but the actual rules are do not cover CC4 structures.
And while I'm looking online, George Savas asks, what is the, I guess coming back to the question, Banali's question, what is the plan in regards to releasing textbooks and aids related to the new code? Looking at Ahmed here.
Yeah, I mean, there are plans being formulated at the moment in terms of guides, different guides. So we'll try to keep sort of the same tradition of producing guides, but it's a bit away because I think one of the complications which I mentioned quickly is these early amendments, which was a bit of a sort of a surprise how effective they can be in terms of changing things. So we have to make sure that everything is completely stable in terms of the main code, and the main code is stable now, but the amendments does change some things, so we have to make sure that this is covered. And then the next step is the national annexes to be finished, and then there will be the guides and so on. So yeah, there are plans.
Third edition of your book?
Maybe. I don't know.
You heard it here first. Any other questions?
Sorry, can I just add to that? We will also be redrafting the published document to make it consistent with the new code. So that's one of the steps when we're in the very early stages of putting that information together.
One question that sort of is coming a lot from clients and others is long-term projects which have started with the current generation of Eurocode, but which are likely to continue beyond 2028. So the question, or there's a lot of debate around that, when does the transition need to happen? Because as you said, in 2028, the first generation will be withdrawn. So will these long-term projects where a lot of the design work has already happened, what is the sort of, is there any, I know there is no guidance around, but what's the thought around that?
So my take on it is that contractually you've signed on the dotted line on date whenever, and that's the code that is relevant. You may wish to look at what is coming. I mean, these codes are already published. They're available for everybody to download. And if there's something that pushes you in a direction to think a bit harder, the displacement limits for geotechnical structures are very useful because there are very little information in that area apart from marine structures. So, you know, I would say you need to stick with what you've got, but don't ignore what's coming, and where you can gain benefit from it, use it.
Ian?
Can I just...
Banali?
Yeah, I think what's it... Oh, sorry. It's Ian Smith from Atkins Realis. Can I just comment, Ziggy? I think that's exactly the right answer. That risk is held by clients. We can advise them, your company, mine, Ziggy, we can all advise them, but the important thing is somebody owns that structure, they have insurers, they have their foreseeable market and everything. That's their decision. We can just advise them. Yeah.
Thank you.
Any other questions in the room? We have one. Oh, yeah, we'll take that one at the back. Sorry, I can't see who that is.
Thank you very much for the presentation. I'm a bit surprised that you never mentioned the word performance-based, and you never mentioned the word risk-targeted spectrum. Like, how do you compare the philosophy of the American guidelines with what you are offering us today?
Well, there are lots of surprises, but but you can imagine there are many views in committees like this, and agreeing on something is always not easy. It takes quite a lot of meetings. I was looking actually back at how many meetings I attended, and they were over 150 meetings in the last few years or so. So quite a lot of meetings, a lot of disagreements. But I guess the answer is there isn't sufficient information for the committee to sort of justify the ease of use that was initially the intention of the code. But apart from this, I really don't have any other sort of information on what the development of the spectrum came from, unless you have anything on the hazard side. So, they decided to follow a simplistic approach, which is a significant improvement from the type 1 and type 2 spectra that was in the first generation, but try to keep it as simple as possible. But having said that, a new thing that is happening in the second generation is that the intention that there will be revisions every 3 to 5 years, which is quite a short span of period. And when you look at what Ziggy and Ian mentioned in terms of contractual requirements and so on, this seems to be quite a short period of time. But that's the intention, and that's already agreed, that there will be revisions depending on the type, on the part of the code. It will be revised, and with some maintenance and revisions from 3 to 5 year cycle, which is quite a lot, I think.
I think on the performance-based point, I mean, I would suggest that that is partly a language issue anyway, because I think European practice, and when Ahmed's been describing displacement-based design and displacement, there's a lot more inclusion of nonlinear response history analysis as an analysis method. There's a lot more supporting information for using that to support your designs. So I don't know that calling that performance-based design adds any value. Ahmed's also talked about the different, the matrix of performance objectives that different countries and their national annexes can include. So I think that's more perhaps just the sort of paradigm that the sort of American versus European language used. But the point about risk targeted is certainly something that hasn't been adopted. I agree on that. On the topic actually of performance targets, I think this has sort of been answered, but a question from Theo Bacchus. Will the satisfaction of the performance targets have to be verified for standard design? And I think you were saying that at least one of the ultimate performance objectives needs to be adopted by the national annex.
Yeah, that's right. But in some cases, as I said, for assessment and for damping systems and so on, you need a bit more.
Yeah.
But typical standard design, you need 1 and 1, which is not really a significant deviation from what we have now.
Yeah. Hopefully that answers the question. Any other questions in the room? Ian again? Or,
Thanks. Ian Smith again from Atkins Realis. I think, thank you both for what you presented tonight, because you really are presenting stuff as live things that are going on in committees and things. So it's really great. Thank you. But I don't think you should lose from the last question. I don't think you should lose sight of the fact that I'm old. When I started out, some of the procedures we were using were just wrong. And it's great to see the codes developing, and at least by going through the codes, whether the thresholds are right, whether it's based on the best information, it's the best we've got at the moment. It may not be at the forefront, but at least people are starting to be aware of all the issues that you've been talking about by going through, following the codes as you've done. the structures will be far more resilient, far more robust than they would have been. So I see us in a very positive place, and updating the codes, I know it's annoying, but I see that as very positive as well. It's the right behaviour to get the best opportunity for the best response, and understanding the materials that we're designing with, because there's a lot of benefit by understanding the material behaviour and the layout of structures and soil structures as well. If we get the structure concepts right, we'll actually inherently have a good robust structure. The thresholds will always be an issue, yeah, but that's probably for legal people when it goes wrong. So thank you very much anyway for presenting the stuff. It's been very valuable. Thanks.
Other questions? I've got a few more on the line. Dina, yep. Please.
Yes, thank you very much, both Ahmed and Ziggy, for the very comprehensive presentation. Of course, the elephant in the room is the existing structures, and part 3, of which I am responsible. I keep quiet. But no,
you can say what you want, Dina, don't worry. You're among friends.
No, I keep quiet. But just to say that, of course, and also linking to the to what Ian just said there, yes, the structures in future will be more robust, but the replacement ratio of new structures to old structure is very modest. Therefore, we need to look at what is already there and whether we accept the level of risk that they pose. And if we change the national annex as we are proposing to do, of course the issue for Wales at least will be to look at CC3 consequence structures and public building and decide what to do in terms of retrofitting. So that also for, let's say, the representative companies in the room, that's something that needs to be thought about.
No response on that? No. Just a couple of questions online. So Anthony Jones says that his understanding is that the UK National Annex to Eurocode 0 will define CC3, but the decision between CC3A and B will be a client decision. I'm not sure if that's your understanding. Given the nature of residential tower developers, is there any compelling reason why they should choose 3B?
Yeah, I mean, there will be some flexibility. There have been sort of late changes in Eurocode 0 in terms of consequence classes. But in part 1.2, we actually do refer to tall buildings, or depending on the definition. I think we define it as 50 meters plus SCC3A.
Yeah.
So this is firmly in part 1.2, according to the definition in Eurocode 8, and this has not changed. So that's what we have at the moment. But I understand, yes, that Eurocode 0 is making these kind of judgments, if you want, as a client. So, yeah, I mean, I would imagine that if there is a very strong reason for you to make a CC3B, it's a client decision, because you are not reducing the performance, you're actually increasing it. Yeah. So there's nothing stopping you from doing that.
And just another question, this one from Zeshan Zafar. Just talking about the way in which the first generation Eurocodes are implemented in FEM software, and I guess just asking, will it be possible to continue to use existing FE software with the second generation codes?
I think you need to discuss that with the software manufacturers. They need to update their software.
Yeah, exactly.
They are already actually engaged in terms of the developing or adapting the codes to the second generation. So I've attended several meetings in BSI where software representatives are attending and they're following and engaging with the process. So they're already preparing for this.
Oh, good to know. Yeah. Okay, any more questions in the room? I've got nothing more online. If not, I think we can once again thank Ziggy and Ahmed for the great talk. Thanks very much. Yeah.